same thing. They're both equivalent, right? So that's how you find the transpose to a matrix. Now, let's talk about matrix addition. So, matrix addition is only possible under one condition. So, the two matrices that we're adding it is an absolute must have the same order. So if I have a matrix that's A here, and let's say A is 1, 2, 3, 4, as what we had from before, right? The order of a matrix is given as the number of rows by the number of columns, right? So the order of A here is actually going to be 2 by 2. If we go back to our example from B, I don't remember the exact value, so I just gonna probably change them. So negative 1, 0, 3, 7, 4, 9, 2, 5, 1. So the order of B here now, if you realize how much rows there, so it's 3 rows, 3 columns. This is going to give me a 3 by 3. I'm going to introduce something odd. Let's say I gave you 3, negative 1, 4, 6, 7, 8. The order of C here now is actually what? 3 rows and 2 columns. So that will give me 3 rows. Rows always come first, 2 columns. Now, here's the thing. The only way you can add two matrices is if they have the same order. So the first thing you have to do is check if they have the same order. If that's the case, then we can. So let me demonstrate with an example here. Quick example for matrix addition. So when we work with the matrix addition, say I have a matrix A, and let's say that it's 4, negative 1, 3, 2. I have a matrix B, and let's say that it is going to give me 1, says 0, 3, 9 here. And let's say I have a matrix C, which is going to be 2, 1 at the end of the day. Cool. Can I find what A and B is? And can I find what is B and C? Can I find what is A and C? Let's demonstrate using this. So first thing is to ask yourself, what is the order of all the matrices? So for A, the order is 2 by 2. For B, the order is also 2 by 2. And for C, the order is now 2 by 1 because we have 2 rows and 1 column. Now, can I find A plus B? The only way in which we can add or subtract two matrices is if they have the same order. So given that A and B now both have the same order, what we can do, we can go ahead and add them. So this is going to give me 4, negative 1, 3, 2, then I'm going to add 1, 0, 3, 9. Cool. Now, when we're adding the matrices, what we do is we add the corresponding positions. So this here is in this position. I'm going to add it to this number over here. So that gives me 4 plus 1, which is 5. So you do the same thing with all the positions. So negative 1 here and 0. That will give me negative 1 plus 0, which is negative 1. 3 plus 3, that gives me 6. And then 2 plus 9, that will give me 11. So that's the matrix addition A plus B. Now let's consider what B and C is. Can I add B and C? No, because the order of B is 2 by 2, but the order of C is 2 by 1. When the orders are not the same, we cannot add them. We said that the matrix addition is undefined. And this is actually an answer that could pop up on a multiple choice exam. So we say undefined whenever they don't have the same order. Let's look at A and C. A is 2 by 2, C is 2 by 1, same thing. It is undefined. And why is it undefined? It's undefined because they don't have the same order. So that's that. So that's matrix addition for you. It's very simple. I'm so sorry that I'm rushing through because we're almost out of time, and I want to show you guys how to do at least one example of Kramer's rule. All right. So Kramer's rule. So Kramer's rule is basically a method of solving a system of equations. And a system of equations could be, say, a 2 by 2 equation, a 3 by 3 equation, meaning you have 3 equations with 3 unknown, 2 equations with 2 unknown, right? So I'm going to demonstrate the algorithm. I doubt we'll have enough time before we get kicked off. do an entire question. But say that we have an equation, right? And say that the equation is ax plus by, and say that this was cx plus dy is equal to, and let's say that this was e, and let's say that this was f. The first step in Cramer's rule, right, is to represent the equation as a matrix equation. So when we look at a matrix equation now, the matrix equation is basically, we're going to take off the coefficient values. So in order that, we're going to label them as A, B, C, D. So this is going to give me the first matrix, A, B, C, D. That's going to be my first matrix there. This is matrix A. We call that the coefficient matrix. This here now, what we do, we label the variables X and Y in the order they appear. So X and Y going across. So I'm going to list them now going down. So X, Y there. Cool. We call this our variable matrix X. Some textbooks you'll see it as a capital X. And then over here, we have EF, and this is what we call our solution matrix, B. So the matrix equation is always AX equal B, and this is very important to us. Now, when you did CSEC math, they told you, or they taught you rather, that X, you can solve for the variables X by using A inverse B, which is perfectly fine. But Cramer's rule is another method that we can also use to do this. Cramer's rule says that if I want to find the variable X, right, then it's going to be the determinant of what we call AX over the determinant of A. If I want to find the variable Y, it's going to be the determinant of AY over the determinant of A. Now, even though I'm demonstrating this using a 2x2, you can also use it for a 3x3 equation. But let me show you how we get the matrices AX and AY. So remember I said to you that A here is our coefficient matrix, X is our variable matrix, and B here is our solution matrix. We get A subscript X, right, by replacing our X column. So this will be X column, this will be Y column. So replace our X column with the solution matrix. So when I get that now, it's going to be E, F, B, E. This will be AX. So to use Cramer's rule, what you'd have to do, you'd have to find the determinant of this matrix, right? And then plug it into this equation here. How would I find AY? AY now, you replace the Y column with the solution matrix and then find that determinant. So AY now is AC, replace the Y column with the solution matrix, EF, that's going to give you AY. So to use Cramer's rule, all you'd have to do now, guys, is basically find the determinant of AX, divide it by the determinant of A, find the determinant of AY, divide it by the determinant of A, and this will always work. There's a proof for it in like higher level math or something like that. If you did a more rigorous math course, they'll actually ask you to prove it. But highly unlikely that they'll ever ask you to prove it on the given exam. So what I'll suggest is YouTube as much as you can for your exam. Don't wait last minute to prepare, and ensure that if you have problems, reach out to somebody who can help you. All right. I hope the session was somewhat beneficial. If I had known that your exam would only focus on the given topics, I would have prepared for that instead of using using past papers. But nonetheless, I hope the session was helpful, and I was happy to assist in any way. Thanks for having me, guys.
Thank you.
You're welcome.